So I would like to go through an example so that you know what's going to be happening of a linear programming problem. So the one that I chose is trees in urban areas help keep air fresh by absorbing carbon dioxide. A city has $2,100 to spend on planting spruce and maple trees. The land available for planting is 45,000 square feet. Spruce trees cost $30 to plant and require 600 square feet of space. Maple trees cost $40 to plant and require 900 square feet of space. Spruce trees absorb 650 pounds per year of carbon dioxide, and maple trees absorb 3,300 pounds per year of carbon dioxide. How many of each tree should the city plant to maximize carbon dioxide absorption? So the first thing that is done is that I'm going to want to make a table. And to make the table, I have to read through the problem again and find out what are they asking me and what are those numbers that they're referring to. What do I not know? So what's my variables? And how do I put this into equations? So I went through the word problem and I read it again and I kind of color coded, and this is, you don't have to color code. I just do this to help me organize my thoughts. So I color coded what related to each other. So there's $2,100 to spend on planting the spruce and maple trees. Okay, so that's going to be the cost for me to purchase these and plant them. The land available for planting is 45,000 square feet. So the area of the land is an important piece. It's creating a restriction, a boundary, which are part of my constraints. And then the spruce trees cost $30 to plant and require 600 square feet of space. So that's specific to the spruce trees, because remember at the question it said how many of each tree, so I need to know about each tree. So I put this information in a table after I color coded it, like the maple trees cost $40 to plant and require 900 square feet of space. Okay, spruce trees absorb 650 pounds per year of carbon dioxide, and maple trees absorb 3,300 pounds per year of carbon dioxide. So, and in the question, it asks how many of each tree. So I know my variables are going to be each tree. It's going to be the spruce and the maple. So I'm saying the spruce is the X, and the maple is the Y. So I identify my variables first. And then I'm looking at, what are they asking me? They're asking me how many of each tree should the city plant to maximize, so I know that I'm looking for the biggest number, max, carbon dioxide absorption. Okay, so what do I know about carbon dioxide absorption? It says that the spruce trees absorb 650 pounds per year of carbon dioxide. So under the spruce tree, I'm going to put 650 pounds per year. And that's times each spruce tree, so times X, because I don't know how many spruce trees I'm planting. And then I look at absorb 3,300 pounds per year of carbon dioxide is the maple trees. So underneath my maple trees, I'm putting 3,300 pounds per year times the Y. The Y stands for the number of maple trees. Okay, and then I'm filling in my costs. So the dollar signs, I'm looking for the dollar signs. I have $2,100, and it says that that's all that the city has to spend. So whatever I spend has to be less than that. So I have less than or equal to $2,100. And it says that the spruce trees cost $30. So under the spruce and in the cost, I put 30 times X, $30 times the number of spruce trees. In the maple section, I put 40 times Y because it's $40 for the cost of the maple tree, and Y, again, is the number of maple trees. That's what I'm trying to find out, how many trees. The land, it says the spruce tree requires 600 square feet of space, so I put 600X underneath the spruce tree and in the land row, and then underneath the maple in the land row, I wrote 900 square feet times Y. Y is the maple. Okay, so once I put together my table from reading the problems, it becomes fairly easy to do the next step, which is it's a critical step to solving the problem if you have to solve the problem from start to finish. But don't be scared, because you have to meet the standard, you have to be given the constraints and the objective function and then solve the problem from there. So this whole first step, you need to be given that just to meet the standards. Now, you are still going to have the opportunity to find the constraint and to provide it through a table showing us how you found the constraints and the objective function, but that is only for exceeding the standard. So it's more points. So instead of a 60% on the assignment, you'll have 90% on the assignment, or 100%, okay? So don't be fearful of this, because you don't have to do this part to meet the standard. Okay, the constraints. The constraints I put are my boundaries. They're my inequalities, the less than or equal to, or the greater than or equal to, etc. So first of all, I'm not going to get a negative number of spruce trees. Okay, it's an object and I need to plant it. So I either don't plant any, or I plant a positive counting number of them. So my X has to be greater than or equal to 0. And it is critical that you do put this into the graph so that you can plot that point, because it will be a critical point. Okay, so more than likely it will be a critical point, but you want that in there, that it's your counting number, so you're not dealing with negative numbers. So X has to be greater than or equal to 0. Your Y, your number of maple trees that you're planting, has to be greater than or equal to 0 also. Okay, then I read across my 30X plus my 40Y has to be less than or equal to $2,100, because that's all we have to spend. So that gives me my inequality, which is my constraint, my boundary to graph. My land, the amount of land that I need for planting, is 600X plus 900Y, which has to be less than or equal to 45,000 feet squared. So this, reading it across, I write my equation and I have my constraint. Okay, my objective function comes from the question. It asks me, how do I maximize carbon dioxide absorption? And it gave me that a spruce tree absorbs 650 pounds per year of carbon dioxide. So I have 650X plus the maple tree is 3,300 pounds per year of carbon dioxide that it absorbs. So I have plus 3,300Y. Oops, I switched places, sorry. And this is what I'm maximizing. It's not equal to something. I'm going to find out what it is equal to when I put it into the equation. Okay, I I think this is kind of cut off on here. I'm not quite sure. I have to realign it. Sorry. Okay, then the next part of the problem is that you go onto Desmos, which I'm going to give you the link to, and you can click on that. You put in your constraints, just type them in, and it will graph it for you. You have to pay attention to how it's graphing because you have a feasible region, which we're going to talk more about in the next video. I'm going to define constraints and feasible region and all of this stuff. Okay, so your region is this area where all of the colors overlap. And then the vertices are the change in direction points. Okay, so 0, 0, 0, 50, 30, 30, and 70, 0. Okay, it's where everything overlaps is inside the middle. That's called your feasible region. And then you have critical points, which are your vertices. And so you click on it on Desmos, and it will label it. Okay, and I will need a picture of this to show that you did it and to show that how you find your critical points. Okay, so then the next thing to solve is once I have graphed my constraints and I found my feasible region and I found my critical points, I take that objective function that I'm looking for the maximum for, and which is 650x plus 3,300y, and I plug in my critical points. I get my solutions because I'm looking for the maximum. I'm looking for the biggest number, which was 165,000. That's the largest amount that is maximized. Okay, now I go to my conclusion. Oops. Backtracked, sorry. Okay, answer the question that was asked in the real world problem. So this is what I got mathematically for my solution, but that doesn't answer the question. The question says, how many of each tree should the city plant to maximize carbon dioxide absorption? If I wrote the point 050 is 650 times 0, etc., which equals 165,000, they'd say, what are you talking about? That doesn't tell me what the answer is. So you have to write the answer to answer the actual question. How many of each tree should the city plant to maximize carbon dioxide absorption? The maximum carbon dioxide absorption is 165,000 pounds per year. Okay? And it is obtained by planting 50 maple trees only, because it came up 0 for the spruce trees. So that's the answer. The city wants to buy 50 maple trees and plant them so that they can have the maximum absorption, because that's why they're planting the trees. Linear programming process, there's 3 steps. Again, the first step you only have to do to exceed the expectations of the standard. The second and third step you will have to do to meet the standard. So it is the problem understanding. We write the constraints, inequalities, and the objective function, the maximum or minimum. And to show your work, you create a table with the information given and identify the variables. And then the feasibility and boundaries, graphing the constraints and identifying the critical points. To show your work, you graph using Desmos and you take a screenshot and you'll insert it. And then the solution, you identify the mathematical solution using the critical points, and then writing the solution to the question asked in the word problem. So that's in words instead of just the math. Okay, so we are going to break